In the previous chapter, we discussed about type conversion and casting behaviors and what are the automatic type conversion that happens in Java. Let us see this in action. In this chapter, we'll do some hands-on exercises which will help you reinforce the concepts that we have discussed and look at how we can cautiously do casting and write proper code and understand the behavior with type conversion. All right, so now let us go ahead and do a small exercise, hands-on, to understand the type conversion and casting behavior we have discussed in the previous chapter. Okay, so with this, let us go and look at this program. So I have a folder type conversion for this, and let me just open / blah 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 type conversion demo.java. So in this code, all I have is a very simple snippet about widening conversions, casting behavior. So the same concept what we discussed in the chapter, what we discussed in the theory chapter, the same thing I have given here on narrowing conversion, and there's a small behavioral thing that we'll observe in this particular place. Let me explain that when we get into it. Then truncation, automatic type promotion, and as well as result exceeding the destination type. So we have different options specified here. So let us do a compilation here. There is an error. I think probably this is the first time we are seeing some errors like this. So whenever there is a problem with your code, or you have not done or written the code properly, you will definitely see errors like this. So this is the compilation error. So now let us understand what are those errors. So remember, for incompatible types, what is required? Casting is required. So this is what it is showing here. Error, incompatible types, possible lossy conversion if you convert directly from int to byte. So it is giving you that hint. And as a programmer, it is your responsibility to be aware that there could be a probable data loss when you do this. And you should say, it's okay, please go ahead. And then the compiler will compile. So this is something we need to keep in mind. Okay. So with this, let me go back to the code. Let us fix this problem. So first thing is in Java line number 12. So if you go to this particular place, I think this is the casting example which I was telling. So this is line number 10 here. So 11, 12. So this is the place where casting is required. So it is telling that B is equal to J. So casting is required. So let us cast this as byte. Okay. So I am explicitly saying convert this. So this casting automatically does this type conversion for us. So this is taken care automatically for us. And next, I think the second one is again the casting purpose here. So we can do this. And the third one is also associated with casting. So all are with casting. So all we have to do is just cast it. So again, integer, automatic type promotion, and int L is equal to F. So here also we are seeing that it is incompatible. So let us cast this to int. So when you're doing this, there is a truncation in this particular scenario, and then finally you would see that it is this particular thing which is also coming into picture. So let me go, and in this particular place I'll have to just say byte. So this is the last error that we are seeing. I'm casting to this, but when I say byte start to, what it will do, it will just cast this one independently and then multiply it by 2. Again, you get into trouble. So the simple thing is you can keep it this way. This is a simple, safer way where we can also ensure that we keep the parentheses and group our expressions in a more logical way which we want. Okay, so now after doing this, let us quickly save this, and now let us try to compile this program again. Wow, wonderful. So as expected, it is compiled. So now let us execute this. So let us go java com.olc.jfsd.jess. So you would see some output. So let us understand what are these output that is generated with reference to our program. So first thing is widening conversion. So now we saw this particular thing, system.out.println. So we have integer is equal to 10 and I'm converting it into a long. So it printed 10. So no problem. Okay. Next is about casting. All right. So casting, what I did, I had 5 and I casted this to a byte. And remember, though it's a bigger jar, it had little water which was able to fit in the smaller jar. That's the concept. So I did casting, and with this cast I am getting the same value. But this is not the same when we go to the next section here. So here we are seeing that narrowing conversion. So here we could see that there is int k is equal to 254. So 254 is almost closer to the range of the byte range, like it starts from 0, 1, 2, 3, 4, 5, 6 and then 127, then minus, it will just come back to 0, and that is what we are seeing here. So 254 is minus 1, so this is what we are specified. But now if I say this plus 1, what would happen to this? Let's observe. Okay, plus 1 is minus 1, plus 1 becomes 0. So 255, it has 254, 255, 256, and then 257 is not there, so it becomes 0, and then it will continue. So if you say by plus 4, it becomes 2, 3, 4, 5, something like that. So this is where the narrowing conversion will come into picture. So it will take only whatever is possible and it will give you that data. So be aware of this important feature and behavior when you are dealing with bytes or any other specific conversion types. Then we will look at truncation behavior. So we have this 12.3. So what is displayed is 12. So this is an example where it has removed the decimal and got only the integer portion. So that is defined by the casting of float to integer. And the last, you're seeing this automatic type promotion. So you have 2 bytes or 3 bytes and we have given an expression and it automatically has given me the output which is an integer. Okay, and at the last we also see the concept of the result exceeding the type and giving again a narrowing conversion behavior here as well. So this is a simple example where byte is getting converted into byte, but since it is not able to, it's like pouring more and more water directly. So putting in the expression is like you're just getting out of some function, right? So that is what is like an expression. So you're just taking the data and it is again casted to byte, and that's what you see in this particular play. So this completes the type conversion behavior. So next we do have another small program in this particular place, so which is C. So let us go and look at the other program, Celsius to Fahrenheit. So here I have another program. So let us close this one. We are done with this. So this is a very simple program to help you understand the concept of, again, how to write an expression and use this concept for writing a program where we have a main program which will take some input. So one more important thing we see in this example is the use of a class called scanner. So you have a scanner available from java.util package, and whenever you want to expect some data to be entered, because every program will not be just computing all by itself, right? So the data could be probably provided externally by the end user. Like if you go to a website and you're going to register on, say, google.com, you have to give your username, password, or whatever details, and then you have to register, right? So this is nothing but giving an external data to a Java program. So this is an example where we can use a command line environment and get the input from the user, where you could say enter the Celsius, and then it will basically give you the information directly to the float here, scanner.next float. So it will automatically take the data entered by the user, convert it into a float and give it directly to the program. So this is the behavior. So you could say next int if integer is expected. So you can basically get this information, and then this is the formula. So I've just given this formula just for your information. It's nothing new, so it's a standard conversion formula. So how do you represent this in a programming language like Java is something which is interesting here. So again, you have the Celsius data, and star are multiplied by 9.0f by 5.0f plus 32. So division will become the first priority, so automatically you get this output which is generated here. So now let us go ahead and try to run this program. Okay, so now let us do a compilation here. We have compiled the program. Now let us execute this particular program. Okay, so com.lc.jfsg.aess. Okay, so you are supposed to enter this degrees Celsius. So let us say 100 degrees. So how much is in Fahrenheit? So you would see that it's 212. So it's a very simple example. So where you're entering the data, so the scanner gives you the option to enter the data. So user is now entering the data. So 0 degree Celsius, if I give, it should give me 32 degree Fahrenheit. So this is a working program for me. All right. So this is a simple example of how you can now anticipate data or expect data entered by the user and take that data and then use it for your computation, where we are feeding the data to the program externally via this scanner class. Okay. All right. So I want you to complete this particular exercise and hands-on. So complete the type conversion and casting a sample, complete the Celsius to Fahrenheit, and I have another challenge for you where you have to write another program where the user is expected to enter Fahrenheit and you are supposed to convert this into Celsius and display the output. Okay, so do this hands-on, complete it, and then give me the program that you have written for Fahrenheit to Celsius. Okay, put it in the comments section below. So in the below comments in the next to the chapter, you can just give this program and send it to me. So I'll just take a look at it and ensure that you should have written properly. So this is something which is important. So I would be happy if you just write the program, execute it, and then send it to me so that I can take a look at it. Okay, thank you, and I will see you in the next chapter, which is arrays. So I want you to complete this exercise and then come to the next chapter. So in the next chapter, arrays, we will discuss about how to use arrays and what are arrays, and we'll also look at single dimension, multi-dimension arrays, how do we represent them in Java.